In geometry, section 5.3, we're dealing with indirect proofs. So basically what we're going to do is we're going to take a proof, and instead of proving the exact thing that they want to prove, we're going to prove that the opposite couldn't happen, and therefore indirectly prove that because the opposite can't happen, then it has to be the original. So here are the steps. Step 1, step 2, step 3, and this is how you write the proof. You just have step 1 and you do that, step 2 and step 3. So there's no two-columnness for the indirect proof, just 3 steps. So the first step is I'm going to take the conclusion. That's a statement that's proof. You know how you have given and prove in a two columns proof? Well, you're going to take the proofs one and you're going to state the opposite. So you're going to assume the conclusion is false. Then you're going to give a reasoning why number 1 is wrong. Okay? And then I'm going to point out that since step 1 is false, so because we proved that the opposite is false, then we're going to assume that the original has to be true. It might be a bit confusing, but here are the steps. They are in your book and they will go on your flipper. So let's go ahead and try one. Let's try an algebraic example, so maybe you can understand a little bit more. Not all of your ones in your homework is going to be algebraic, but we'll try this one. So go ahead and write this. Put the vocabulary words in as well, and we have one example. Okay, so basically here's our given and here's our proof. Okay, our first step is to assume the conclusion is false. So our first step is to take this and we're going to change it. So because y does not equal -2, then the opposite is y equals 2, right? Our next step, step number 2, would then to use this and prove that this is false. Okay, so what I'm going to do is I'm going to plug that in. In this one, this is the one where you can use a theorem, you can use, the reasonings that we usually have, where you have the statement. So 2 is where you usually put the reasoning. In this case, because it's algebraic, I'm just going to plug it in to see what happens. So if y equals 2, if I was trying to plug this in, I would plug in any number except -2. Sorry, this should be a negative. Okay? So I'm going to plug it in. Y over 2, and we're going to put in -2 for y, plus 4 equals 20, right? I have y 1 over -4 plus 4 equals 20. And for this one, 1 over 0 equals 20. Because this is 1 over 0, this is then undefined. And this is my work for number 2. It shows me that it cannot equal -2 because it gives me 0. So, my last step is just to bring it all together. What I'm stating is, because y equals -2 gives me an undefined answer, I must conclude that y does not equal -2, which is my original statement there. So I've indirectly proven that y does not equal -2 by proving that if y equals -2, I get undefined. And that is an example of indirect proof. Now go ahead and try page 291, numbers 2 and 5. Number 2 and 5 on page 291, and number 5 might be a little confusing, so just try your best, and if you don't get it, then we'll work on it in class. Okay, see ya.